on the electrical solutions.
Yes, thanks, Vincent Yamwai. I hope everyone can hear me and see my screen by now. So this is the fifth session of Systems webinar series, stay-at-home initiative due to the current situation going on. So hope everyone's keeping healthy, and let's begin. So as Vincent mentioned, the solutions we'll be looking at are OpenUtilities Substation, which is Bentley Systems substation modeling BIM software. And important thing to note here actually is that OpenUtilities Substation is a 3D solution. However, we are able to, it sits on top of MicroStation, as well as Bentley's Promise E, which is the 2D modeling and drafting software for electrical solutions. So OpenUtilities Substation is actually a combination, you can say, of MicroStation, Promise E, and then finally has the 3D modeling capabilities to create an intelligent 3D substation model. So a quick highlight of some of the features that the software has. You are able to create a single intelligent substation model that actually combines your conceptual single line diagrams, your panel layout drawings, as well as the protection and control schematics. The design is centered around an intelligent parts database, which we will see when I go into the software. But that is to say, the equipment and the symbols that you place are not just generic CAD models, rather they have some intelligence within them that actually makes the whole modeling and post-modeling procedures, such as generating your bill of materials and construction drawings, much faster and much easier. The third point I'd like to highlight is there is also clearance and clash detection available, so you're able to maintain some space reservations, and you can observe your clearances and ensure that your model is clash-free before you actually release it for construction. There is also lightning protection simulation using the rolling sphere method, where you can visualize if the entire substation is protected by the parameters that you will define. And also this model then can finally be pushed into software such as ProjectWise, AssetWise, or basically any Bentley software. In my case, I'll be using this example with the other software, which is Bentley Raceway and Cable Management. But because Bentley software actually all use a common file format, there is very smooth interoperability, as well as you saw in the previous slide with the iModel Hub, so on. You are able to share these models and actually use it for asset management, project management, and so on. Okay, sorry, skipped a few slides there. I'm just going to go back into here. All right. So common CAD problems that we face, and I'm going to show you and explain a little bit on how actually OpenUtilities can help solve these problems. So we have some design automation features that I will go through in a while, which actually minimizes the time and effort spent on common drafting tasks while also increasing your design quality. There's a data manager where you can overview all the equipment and symbols that have been placed and make changes in groups, whereby you don't have to navigate to each individual page and make the changes over there. There is a project-centric database which combines primary and secondary design. Once your entire design is complete, you can generate reports based on the designed files that you've created, and you can also create a smart PDF smart PDF reports, which I will show you later as well. OpenUtilities Substation now also comes with a work order management tool, which you can streamline your work orders, and you can integrate your software with the enterprise level software such as SAP and so on. And for 3D design, it's not just about placing the 3D components, but it actually comes with the Hooks Point technology, where you are able to snap and quickly create your substation 3D model very fast, which we will also see in a while. So I'm going to jump into the software for a while just to give you a quick overview of the interface. So this is sort of the project that the demo project I've been working on and we'll be using for our example. So we have two bays over here, a control building as well as a terrain model. So I've used a standard flat sort of terrain, but you can also keep in mind that this terrain can take into accounts reality models and different topographies. So it's not necessary that this only works with a flat surface. You can actually have any sort of surface and model on top of that. So two things I'd like to highlight before we get back into the slides is actually the software comes with a parts database manager, which I actually highlighted earlier. So we can have a look at that. So I'm using the default one that comes with the software, but you can create your own parts database for your company or for particular projects, and those can be reused for your future projects as well. So once it's done at the beginning, it can actually be utilized throughout. I mean, you can keep adding to it, modifying it, so on, and basically use that one parts database through all your projects. So what we can see here is some default fields such as part numbers. We have some manufacturer information. I can skip through, but what you're seeing here is just some default parts available. There is some symbol data where we assign our 3D symbols. You can assign a single line symbol, and you can also insert your schematic or panel layout symbols here as well. So this is how the parts database manager works. And for symbols, we come into 3D design and I can open up this dialog for insert substation objects. So what you see here is actually a few different fields where you can insert symbols by name, part number, device ID, and as macros as well. So I will go into those a little later, but what I would like to highlight now is that these are different catalogs that come with the software by default. And you have access to a lot of 2D and 3D symbols via these catalogs. And our side, from Hertford, I've also created our own custom catalogs, which take into account Malaysian and Southeast Asian standards, which is following the IEC standards as well. And we have all those catalogs available. So basically, you are ready to start modeling based on what we have. All right, so I will go back into the slides and we will look at a couple of videos on how OpenUtilities actually works. So this first video is an example for some of the basic wire drawing functions. So what you actually are seeing is how we can draw sort of smart wires, and the software actually suggests parts in which you can place those wires. If not, it's easily modifiable as well. You can just click along the grid wherever you wish and draw the wires. What you're seeing now is a smart move function where you can just select the object and it sort of smart moves it along the wiring lines as well. So deleting the object will automatically heal the wires. As you would have just seen, the wires automatically close. And what they're showing here is actually copying the fuse from the fuse symbol from below, copying it to the top. And you will also notice that you might have noticed that it automatically changes the device ID. So that is to say, the device ID is not replicated. It will automatically take up a new unique device ID, and it will actually follow a sort of progression. The next video is for the automatic wire numbering tools. So you'll see in the design right now that there are no wire numbers available. So using the automatic wire numbering, you can select your parameters. So over here, you can select which pages you want. If not, you can do it for the entire project at once. You can select your modes and then you put in your parameters, which is the first number, what interval to leave, any gauge, color types, voltage level, so on. You can put in all these values. And also you can highlight which position on the wire you want the tag to be. So over here, we're selecting the pages on which we want to do the automatic wire numbering, and then give it a couple of seconds to run, and you'll notice that unique wire numbers are automatically generated based on the parameters specified. So we're doing a very simple one here using just numbers, but you can also include some prefixes and suffixes. So you can have a letter before or after the numbering. And we've also developed some customized plugins whereby the sequence doesn't necessarily need to be in order. You can go by even numbers, odd numbers, or you can even define the spacing that you want. So this part of the video is actually showing that you can manipulate the labeling based on your requirements or different wires. So just now we've included some additional information to the wire text that was there. And we're going to modify this label for wire number 19 as well to include some different parameters. You can include an offset, you can change the alignment, and what they're doing here is you want to be able to see the wire tag and the properties for all branches, the same thing which they did earlier over here. So that was automatic wire numbering, one of the most sought after features and actually more very useful features of OpenUtilities Substation. The next thing we're going to have a look at is actually the cable manager. So in your 2D drawings, you will have some field devices which will be connected by cables, and you can manage these cables using the cable manager tool. So changes made in the cable manager will actually be reflected throughout your entire project. So it lists down all the different cables that are in your current project, and then you can modify the cable attributes, and you can change the groups of cables in one go. It's not necessary for you to change it one by one and go into each page to make your changes. Using the cable manager, you can basically, as the name suggests, you would manage all the cables that are available in your project. So what they're doing here is actually swapping the to and from location, and there's a lot of different functionality. Maybe if required, we can organize a more detailed session where we can get into all of this. But because of our time constraint for these webinars, I'm going to move through this, just highlighting some of the key features. So this one, just now we saw the cable manager. There is a similar feature for all the equipment that's available in the software as well, and that is accessed using the data manager. So you can actually modify device IDs, wire tags, any page descriptions, part numbers. You can change it all on a global scale that will reflect throughout the entire project. So again, this is another automation feature which is not basically achievable using generic CAD software, and actually helps reduce a lot of errors. So I'm going to go through this again, skip through this as well, but if you have any questions, please feel free to drop it into the chat box, and we have our team available in chat as well. So they would be able to reply you, or if not, we can get back to you later with more detailed information. So this part of the project, this part of my presentation is just to indicate the different reporting capabilities. So over here, OpenUtilities Substation comes with some default reports available, and you can preview these reports. You can also create drawings from these reports that can be placed into your schematic drawings or into your you can generate a table of contents. You can generate a lot of different reports, as you can see on the left-hand side of this panel here. So you can generate these reports, and then you might have also noticed that you can export these to a lot of different file formats, including PDF, Excel, XML files, and so on. So moving on, this next one is about placing the basic error checking. So the software comes with some error checking capabilities as well, and this video highlights the more basic ones, which is checking for duplicate device IDs. So you'll notice that you get this pop-up message indicating that the device ID you're trying to assign has already been used. So these simple error checks actually help your design to be a lot more efficient, and in a way you don't for example, over assign a contact. So maybe you're using a relay, and the relay has about 4 contacts, but the software will actually be able to recognize that the part number that you're using has already been fully utilized, and then you might be suggested to move on to a new relay with more number of contacts and so on. So this other error check is actually for the wire numbering as well, and just like device ID, it's able to highlight to you that your wire numbers have actually been duplicated. So to move on to a new wire number. This video is highlighting the API builder. So the API builder is also included with the software, and what happens here is you can say it's almost magical, and your drafters would be really happy because your standardized models can actually be replicated inside Excel using some parameters which you would have noticed earlier. So what happens here is you just modify some cells in the Excel file, you add in some extra data or whatever you wish, and the software is actually capable of creating your schematic drawings, and not just schematic, but you can actually create your entire project. You can do your schematic drawings, single line diagrams, panel layouts, and up to your 3D model as well. But the great thing here is actually, even though it's being automatically generated, all the devices will have unique IDs. They'll take up unique wire numbers. So it's not just placing graphics that you have to later assign some intelligence to, but it's already automatically placing intelligent objects. So the next video is actually an example from Burns McDonnell, how they've used OpenUtilities actually on a very high level with their SQL manager, as well as creating a custom GUI. And we can have a look at how they actually use this to create a API plugin. They've actually created a plugin.
Here you can see our user form in action. Selections for some criteria are dependent on other selections. Voltage class determines BIL. Breaker arrangement determines number of line positions. The BIL, in turn, affects phase spacing and clearances. And the operating current determines bus and cable size selections.
So they've created an interface whereby actually specifying your voltage class, you can define certain elements within the substation following the design rules. So choosing your voltage class, they're able to define the number of positions, what sort of arrangement is being used, the continuous current level, the short circuit current level, as well as the BIL.
As an example, we'll fill out the criteria for a simple 4-position ring bus arrangement. Once our selections are made, the data is calculated and a list of appropriate macros is generated.
So their plugin is actually used to create the Excel file which we saw earlier. So you can either manually fill up the Excel document as you wish, but in their case, they've actually created a plugin which helps fill up the Excel file, which then goes into the API.
Using our prescribed spacing criteria, the list of macros along with their position on the coordinate system are saved. The spreadsheet is then fed to the software to generate our complete customized substation layout.
So in this case, they've actually used the software to create a 3D layout using a plugin as well as the API builder. But the entire thing, if executed well, can actually create your entire project from single line right up to the 3D layout, including the schematic and the panel layouts as well. Here, so we'll go next and we can have a look at the smart PDF reports that are actually generated. So maybe I can skip through this video a little bit, but basically this is generated automatically by the software and can be opened up with your PDF readers. So they're using Adobe here. But you can see here how on the scrolling bar on the left-hand side, how each equipment is actually defined separately under main categories such as cables, terminal blocks, equipment, and so on. So you can actually navigate, and it's almost as though you're using the default navigation tool within the software, but you're using it in a PDF. So you can easily locate what you're looking for, and it's considered, this is considered a smart report. And in the 3D environment, you can actually export a smart 3D PDF as well. So you are able to have your 3D model, which can be rotated, different views can be applied, and you can actually have your 3D model in PDF format as well. Okay, so I think now we're ready to have a look at an example from actually TNB. So TNB is one of the main users for OpenUtilities Substation, as well as Promise-E, BRCM, and other Bentley electrical software in Malaysia. And they had a requirement where their graphical part lists they needed it to be bidirectionally navigatable. That is to say, you can navigate from the schematic into the GPL, as well as from the GPL back into the schematics. So it's important to remember that the software is very customizable. You are able to create your own plugins, and if not, the plugins can be created from our side as well. So what happens here is we are running a plugin that was developed for TNB, and we can have a look how this plugin works and how the GPL, which is the graphical parts list, is actually generated. So running that plugin, you will notice how it's actually extracting data from the software and automatically filling up this GPL. So we'll just give it a second to run, and after that we can see how the navigation actually works. I'm just going to jump through here. So the GPL has actually been generated, and you will notice that there are some cross-references underneath the symbols. And it created 3 pages of the GPL. I'm just going to skip through, and then we can have a look at how this actually navigates. So you can click on the cross-reference that's there underneath the symbol, and you can navigate either to your schematic mode or your panel mode, and it works the same way as well. So you can actually navigate now from here. You can go back into the GPL. So this was a plugin that was actually created by for TNB's purposes. All right, so before we go into clearance detection, because this is actually some 3D functionality, let's go back into the software. I'm going to open up Bay 1, which is over here, and we're going to quickly place some equipment, and I can show you some of the features of Bentley Substation. So I have this model here, but I have this space in the middle where I actually want to place a circuit breaker. So I'm going to visualize my construction lines, which I've actually drawn to create a reference for where my circuit breaker should be. We can come into Insert Substation Objects, and there are a few ways in which, as I highlighted earlier, you can locate your symbol. So I'm going to use the first one, the basic one, and look for this part number, which is 1 second. Okay, just give me a minute. So I need to bring in a catalog actually. So I'm just going to import a catalog. So this is a custom catalog that was created for this particular project. So I'm just going to bring it back inside. All right. Just bear with me for a second, please. So this is the back end of the program actually, where all the information actually lies. So I'm just going to go into here to check something. So going to the IC example, going to standards. Okay, so this catalog is here. I'm actually just going to remove it first, close this, and then I'm going to import it back. Okay, so just give it a couple of seconds. It's going to come into the software. All right, so once that's done, you can see we have this new catalog here with our symbols inside. Okay, so now we're ready to place this. I'm going to look for the symbol I was looking for earlier, which was a FD7511. You can see in the description here, it's actually the foundation block for an ABB circuit breaker. So you double click on that, and then you'll have it available to place. We're going to place by the method called DTM. So now this is a great function, because what actually happens here, you can see it clearly in my side view. So it takes into consideration the ground that we have defined. So if this ground was sloped, it would actually follow the different slopes that are available if you place by DTM. And if you wish, you can actually put in some elevation here as well. put in some elevation, then you come back into the software, and you can see that this foundation block has actually been elevated by 200 mm, which we had specified. So I'm coming back into my isometric view, and I'm going to place the equipment here on the center point here. So if you attended the microstation session, you would know that we can snap into these intersection points. So I'm not going to go into details on how that is done, but if you have any questions, please feel free to ask. So now we're going to have a look at how hook points are actually used. So this is the symbol that I'm looking for, and I'll bring it out here. So this time I'm going to leave the method to be hook, but what you can see here now is that okay, so you will notice that on the left leg on this side, there's actually a hook point over there. And if I zoom into my steel structure, sorry, the foundation block that I've placed, maybe I'll, you will notice that there is a hook point here on the left side, and there is one on the right side as well. So what this actually helps us do is we can determine on which side we want the junction box. So I'll move this a bit outside so you can see. Right now the junction box for this steel structure is on the left-hand side. But depending on which point you snap to, you can actually take into consideration which side you want this equipment to be. So I'm just going to place this here. You can actually just get very near that point and it'll try to place it there automatically. So that is exactly how hook points work and how it's very useful when we come into substation design, because we have some flexibility there as well. So the last equipment that I'm going to place is the actual circuit breaker. So now this is a great method where we can place by ID. So you can see an X mark next to all these equipment. And the great thing here is that it actually shows you that the circuit breaker 1 hasn't been placed. So we can just basically check off all the different equipment that we have available, and then you can place it where you want to as well in the software. All right, so we can, next thing we can have a look at is actually maybe drawing cables as well. Drawing cables is a very straightforward process in substation where you have a few different methods. You can click on the cable type you want, and this works with hook points as well. So I can click on this point and it automatically tries to find the nearest hook point to which it can snap to. So it's found the hook point here, which is the one that I want. You can click on that point and you can define some different types of seg. So we have for rigid bus bars, there's a catenary seg for overhead lines, and there's a spine seg which we can use for in between components. So I'm going to give this an offset of 200 mm, and you can have a preview where it just shows you with a solid line. And if you're happy with that, you can just say OK, and it'll generate the conductor for you. And this conductor is not just graphical as well. If I go into its device properties, you can actually see it specifies what the length is. So it takes this length, and then finally when you're generating reports, it can generate the length for this entire thing, for all the cable conductors that's being used. Okay, so there is also, it's important to note that we can do some grounding grid design. So once you're done with your modeling, we can do some grounding grid design. And the last part of that is actually going to be lightning protection as well. So grounding grid design is very simple. You can define that you want it to be with respect to your digital terrain model, or DTM, with a depth of 300 mm, and I'm giving some spacing to be 10 meters by 10 meters. So you can just click on place grid and you draw it basically where you wish for it to be, and it's going to automatically create this sort of grounding grid with an offset of 300 mm. So we have a grounding grid placed. These wires can be modified, so you can delete them. Each individual segment can be deleted. You can place wires, new wires where you want, and you can also modify these wires as well. So let me just remove the grid lock, and you can modify how this wire goes, so you can have it go around the equipment. And the last part also is for connections, so you can actually create connections from your grounding grid up to the steel structures to ground the equipment. And the wire that's drawn up to here will also be considered in the length. So if I close this now, I can open up this dialog. You can actually see it'll give you a summary of how much wire has been used, how many T connections, how many X connections, how many grounding rods are available, and how many connectors are used as well. So this one, it can be extracted here, or if not, you can even place it into your different drawings. You can export it and place it in your drawings. Okay, I'm sorry if I'm going a bit fast, but the software actually has a lot of functionality, and most likely we will be hosting more webinars where we can get into more details on what the software can do. So the last part I'd like to show you is actually the lightning protection. I've already created some earth masks here. We've already created some earth masks, and we'll be using that as our reference. So I've already defined some parameters here. So what we can do is we can process it. So I've defined the masts as well as the cables. You can see they've all been highlighted. So we have two overhead cables here, which are using as a shield wire as well as your lightning masts. So running this simulation, you can, maybe I can go into a transparent view. So we go into a transparent view, I'll go into my side or front profile. You can actually see that the rolling sphere simulation shows that all the equipment that's been placed, including the control house, is actually protected based on the parameters defined here. So once you do that, you can actually group them into different elements, and you can generate some reports as well and create drawings. Again, I'm not going to show that, but basically what happens is you can create some sectional views in between your masts. So we can create a sectional view between these two masts, and these two masts. And it'll create some drawings which can be placed into your 2D files for lightning protection, and any changes made to the 3D will automatically reflect in the 2D as well. So that is a very quick run through of what OpenUtilities Substation, some of the basic features where we look at the 2D and 3D. This one is for the clearance detection, which I highlighted earlier that the software can do. So we're able to reserve some space. You can run some clearance check and check your face-to-face or face-to-ground clearances and so on. So this video actually highlights that. We're going to open up the clash detection and check for phase 1 to phase 2 clearance, phase 2 to phase 3 clearance, as well as phase to point cloud. So we've imported some point cloud data into this model as well, and we're going to check for some clashes in between that. So what's being run here now is the phase 1 to phase 2 clearance with a value of 4 meters. And you can actually see in the results that there are a lot of clashes, and going to them one by one highlights which cables actually don't follow the restriction, that clearance of 4 meters. So the same thing is being done from phase 2 to phase 3 as well. I'm just going to skip through all of this, and then the final one is for the point clouds. So what happens here is you can also export the results into an Excel file, and then you can open up the Excel file to see where the different clashes are, what the type of clash is. It was a clearance clash, and it'll give you the actual coordinates of the clash. Okay, so we're going to go next, and this is an example of reality modeling and how we can use it to create an intelligent model as well. So this one is using Google Earth. We get a topography of an actual site of the substation. So you can use that and then bring it into the software, into Bentley Substation, where you can place your actual components based on the real site. So you can place equipment, you can draw your conductors. Basically, rather than drawing on the DTM that I had defined earlier, you can use the actual reality model as a reference to draw, to create your substation model. So you can see that a bit clearly here in the next slide as well. So using this reality model, it's a hybrid environment which includes the reality model as well as your OpenUtilities equipment model over here. And the modeling flow is basically just the same, except you have a more real reference to your environment, because the reality model is to scale. So if you had attended our context capture session earlier, you would be more familiar. And this is just an example how we can navigate again in between the different modes. You can go from your 3D layout into your 2D as well as your schematic and panel layouts as well. So that is a quick overview of OpenUtilities Substation. I have a few minutes more where we're quickly going to have a look at Bentley Raceway and Cable Management. Now, Bentley Raceway and Cable Management is also a high-end software, which basically there's no other software on the market that can do what it does. And in a second, you will see the few features that the software can actually, the features of the software, which I will go through. So what is BRCM, or Bentley Raceway and Cable Management? It is the first and only application that improves quality and efficiency of raceway design by integrating your intelligent raceway system and automatic cable management. And you can also create drawings, which is the 2D views of the raceways, and you have some reports as well. You can create some reports as well. Okay, 1 second. I'm just going to go back to my previous slide. So this is the typical workflow with BRCM. The cable list can be imported. So this cable list, ideally, in a perfect workflow, would come from your drawings in Substation. So you would finish modeling in Substation, you can extract your cable list and then import it back into BRCM. So once you import it, you can place your equipment, you can create a raceway design, you can create the preliminary and then a detailed raceway design, you can do some cable routing and then generate your reports. So I'm going to quickly jump into the software. So this is what I have. This is a reference to our previous model, and references are quite great again because we are using the same file format. So if I come into here, I can open up my references and you can see this is the model. It actually comes from Substation. So you can go into settings, you can just have a quick look. So this is from my Substation file where the project is actually saved. And you can even turn this reference on and off quite easily. So I'm going to keep this here. You'll notice that this file is called equipment. For Raceway, there's actually 3 basic files that are required. You require the equipment file, you require the Raceway file, as well as a routing file. And in a second, you will see why. So in this equipment file, I'm doing something very basic. We just have 2 panels which have been placed inside this control building. And I've also placed 2 marshalling kiosks in the side. So we have one here and then we have the other one here as well. So you can see it in my 3D view here. So once the equipment is placed, you can see that in the ID manager as well. So what happens in the ID manager, you can place this equipment. Just give it a second to open. So you can see I've placed 4 different equipment here. This is some other extra equipment that of course we don't have a lot of time to go through. So I'm just using the first 4. So we have the 2 MKs and then we have the 2 panels here. And before actually doing this, I've already imported my cable list as well. And let's go into Raceway now. So in this Raceway part, I've actually already created some raceway inside the building. It comes out of the building and enters a trench system. And this trench system then reaches the marshalling kiosks. So I will quickly go through some of the drawing methods available. So if we go into Raceway, we can route raceways sort of in an array format. So this one, I can add another column and I can add another row. I can copy the values from here. So I'm just going to copy and paste just to get something out quickly. So you can paste this. You can define your parameters here. So you can be a cable ladder, a basket, conduit, or a cable route. I'm just going to keep it as a ladder. And we can specify the values here as well. So I'm going with 300 width and 100 height. So what we can do after that is we just do a route. I'm going to create something outside here, and then I'm just going to draw a straight sort of system here. Okay, so I'm going to exit this, and if I go into a closer look, you can see that it actually creates 4 raceways as per the array that we had defined. So taking the same parameters, 300 by 100 cable ladder, you can create an array system here. Okay, so we can also modify this raceway. So for example, we can copy it with some sort of an offset. So I can select the object that I want. You can specify a vertical offset, and then you can see that it actually creates the same component with a 0.5 meter offset as well. So another great feature, the one I'd like to show you most, is actually where you can use lines to actually generate your raceway. So I'm just going to have some smart lines, and this is actually useful for people who have any CAD files with the actual raceway highlighted in lines. So what I'm going to do here is I have some simple lines here with some horizontal bends as well as vertical bends. You can go into raceway generator, click on the line, and you can choose now. So this time we can choose a cable tray. We can put in the variance, maybe 300. I'll reduce the height to 100 as well, go with the same parameters as before. And you can click OK. So this actually generates your raceway automatically, and with the bends as well as, vertical bends and horizontal bends as well. So this is just a few features on actually what the software can do. So I'm going to delete this first. You can actually assign IDs to these raceways. You can extend the raceway. You can insert different parts. So if I go into my wireframe mode, you will see that I have some T-junctions here. So you can actually just insert part. It's quite simple. Select on insert part, select the equipment. Select the raceway in which you want to insert the equipment. You can choose the type of bend you want, and then it actually just gets placed in there. Very simple. Okay, so I'm going to exit that. And not only raceways, but when we go into underground systems, following the same method as raceway, you can actually create some duct banks, and you can create trenches as well. So this is an example of a trench that I created. But you can also create some duct banks, and this duct bank concrete, actually, once you create the duct bank, you can specify some sort of thickness of concrete to go around it. All right, so again, I'm sorry I don't have a lot of time to show you all of this, but we can arrange for a more detailed BRCM session if we have a request to do so. So once you've actually placed your equipment and drawn your raceway, the last part of this is actually to go into the routing. So what happens in the routing is actually the part of the software which has the higher value. Just give me a second. I've accidentally opened the Explorer. I just need to close this quickly. All right, come back into my references. I've attached the raceway file as a reference. I can remove this, and you can see I've already routed some cables. So I've routed some cables to these equipment, and you will also notice that it follows the paths that I specified by my raceway. And the great thing here is with the new Connect edition for BRCM, you can visualize each of the cables. So you can visualize the cables, and you can actually see how this cable is reaching the target. So I can bring back my reference file now. I took it out just to have a look at what we have. But if I come into a transparent view now, you can see the entire system, including the raceway, and how the cables are actually following the specified raceway and going all the way up to the MKs in the field, up to the marshalling kiosk in the field. So to achieve this, it's quite simple as well. So I'm just going to go into Cable Designer. We can go into the Cable Manager. We can go into the Cable Manager, and over here we can see the routed cables. The ones highlighted in red are actually because I made a couple of changes. They are modified, but we can see the actual value for length here. So these different length values are very accurate, and we ran a case study in Malaysia, and we found out that the results that we achieved through BRCM compared to what was actually on site, the difference was just by a few millimeters. So using BRCM is actually a great reference for maybe procurement and so on, so you don't over order any cables, and you actually save a lot of money, because these substation cables, as I'm sure you're all familiar, it's extremely expensive. So having a good estimation on the length of these cables and actually using the software to create different design conditions, you can come up with the best most efficient solution, and of course the most cost-effective solution as well. I'm going to go back into my slides to have a last look at the 2D extraction. So this is an example of a raceway system that comes with the software for a plant environment. So we're just going to have a quick look at the 2D extraction of that. And you will notice how it creates sort of this drawing file on this side. And we can just skip through. So we're going to place a section here. I want to get a 2D section of these two raceways at this point, and then you can bring out a pop-up table that actually indicates section 1, what are the details inside. So category of cable, it's a low voltage cable, it has an ID, it's filled up to 15%, and the different sizes, so the width, the height, and the elevation as well. And you can put in a tag as to where this section 1 was taken, which is from here. And the great thing about BRCM is actually you can specify beforehand when to alert you. So maybe your raceway is 50% full, it will highlight the raceway in a yellow color. If it's 90% full, it will show in red color. So you can customize the software. It's extremely customizable. You can even define that this particular raceway is only for low voltage cables. This other raceway is only for communication cables. And there's a lot of functionality you can actually achieve through BRCM. This is an overview of the cross section, the cables that are inside the section that we just had a look at. And finally, I'm just going to skip through, but basic labeling of the entire system. So they're creating some section views, a lot of different sections actually. Okay, so I'm sure you all have a lot of questions. I had to run through the software extremely quickly, but I hope I was able to give you all a good overview of OpenUtilities Substation as well as BRCM, and we're ready to move on to question and answers, and as well as hand it over to the plant session, which is going to be conducted by Fariz after.